All right, so this section is pretty much all about evaluating your limits. Some of these rules are going to be very basic. Some of them are going to be a little bit more into them, but we're going to start with some very basic ones. So let b and c just be real numbers, and let n be a positive integer. So if we had a limit as x approaches c of a constant, it's going to equal that constant. Okay, constant being a number. Okay, limit as x approaches c of x is always going to be whatever that c value is, if it's just only x. And then if we have the limit as x approaches c of x to the n power, it's going to be c to the n power. So basically, if this is a constant and we're not having anything more than either a constant or an x, it's pretty much straightforward what the limit is going to end up being. All right, so we have here b and c are real numbers, and n is a positive integer. And if we have these limits up top, limit as x approaches c of f of x is equal to L. Limit of g of x as x approaches c is equal to k. Here are our 5 rules with regards to these limits, whether it's multiple, sum or difference, product, quotient, or power. All have their own rules. Please pause this video, jot these down. They will come in handy throughout the section that you might have to apply. So the limit of polynomial rational function are pretty basic. If it's a rational function, you're just putting in whatever x is approaching into your numerator and denominator for all your inputs. For a polynomial function, it's simply just limit as x approaches c of p of x would be equal to p of c. And then it's whatever that value ends up being. There are times when we have a limit like this, where if I were to evaluate it, you would get 4 minus 4 over 4 squared minus 16. That's 0 over 0. Sometimes that would just simply not be undefined and not work. Other times we have to do a little bit more work. Okay? And one of the things we can do is if we factor, which we have to do still, hopefully you didn't forget how to factor. So if we factor the denominator, we had x minus 4 times x plus 4. So that's going to get us, we can eliminate x minus 4 out of the numerator and denominator, not equal sign, which is going to get us 1 over x plus 4. If we evaluate at 4, we're going to get 4 plus 4 is 8, and your limit is going to be equal to 1 over 8. Okay, so always look to see if we can simplify it anywhere. Okay, and one of those times might be factoring. So this is another one that's going to get us 0 over 0. When we have radicals involved, one thing we might have to do is rationalize. Okay, even though we are used to getting rid of radicals in the denominator, that's bad. But in the case of limits, sometimes that's our only option. So I'm going to multiply the top and the bottom by x plus 5 plus 3 to both the top and the bottom. And see if we get an actual answer for this. So if I'm going to leave the denominator as is. Okay? For now. And then the numerator, if we FOIL out, we're going to get x plus 5 minus 9. Which we then evaluate and simplify a little bit. So we're going to get 0 over 0 so far, but look what we got. We got, I can't equal it yet. I need to still write the limit out for proper notation. We still have to write the limit out until we actually finish evaluating that limit. We get x minus 4 on the numerator and x minus 4 on the denominator, and this whole thing, I'm out of space, so I'm just going to say put that there as well. The x minus 4's cancel out. So now I'm evaluating the limit as x approaches 4 of what? 1 over square root of x plus 5 plus 3, which comes out to be a little nicer, right? 1 over square root of 9 plus 3. 3 plus 3 is 6. So your limit is going to be 1 over 6. I appreciate you watching, and we'll see you next time. Bye-bye.